Hello and welcome to R&D Mathematics. Today we are going to talk about inverse functions or inverse of a function. Now, first of all, inverse for a function exists if and only if that function is one-to-one. Inverse, so the first note, inverse exists if and only if the function is one-to-one. Now let's have a look at what inverse means. When I explain that, you will automatically understand what this statement is. Now, the famous diagrams that I have been drawing again and again. This one. So domain of this function, range of this function, let's say the function f, and it takes, let's say, a, b, c, d, e to p, q, r, s, t. So this is a function first of all, and it's one-to-one. So one-to-one function, right? And let me recall you the other two diagrams quickly. The second diagram I draw, this is not a function because it's one-to-many relation, but many-to-one relation, that is a function. It's not one-to-one, but still it's a function, right? Now we have been talking about this again and again. Now look at this this first one over here. What will happen if I, these points a, b, c, d, e, through this function, a is going to p, b is going to q, c is going to r, d is going to s, and e is going to t. What if I reverse this? Now let me draw. So what if so this guy is actually the second oval shape. So P, Q, R, S, T and A, B, C, D, E. So is there a function taking back P to A, taking back Q to B, R to C, S to D and T to E? And yes, there is such a function exists, and we call it F inverse, and the notation is this. Now domain is this, range is this. So if you observe carefully, let me use another color. Domain of, it's better to write domain of f, domain range of f. Here domain of f inverse, range of f inverse. So domain of f is same as range of f inverse, and range of f is same as domain of f inverse. So vice versa. Now let's see this statement right here. Why we only have inverse function for one-to-one functions? The reason is pretty obvious if you think carefully about this guy. Let's take a function which is not one-to-one. Function which is not one-to-one will have something like this. So 2-to-1. Let's say AB goes to X. No, let's say U. AB goes to U. What if I reverse it? What will happen is now U goes to A and B, but it is not allowed to be a function. See here. So that's the reason. So remember, inverse exists only for one-to-one functions. But that's just the theory part. Now we have to get a little bit technical and how to deal with this mathematically. Now, as we explained, let me draw this diagram again. This is domain of f and this is range of f. So this is f, and let me use another color. This is f inverse. It comes back, and the range of f is domain of f inverse, and domain of f is range of f inverse. So remember that will always happen. That's the first relation that you know. And then also notations, we have already been using this notation, but I have to tell you something. Notation, so f inverse, so f of inverse of function f, normally we call it f inverse, is f raised to, it looks like f, negative 1th power, but it's very important to note f inverse, it's not 1 over f, right? So there are sometimes in mathematics, there are places where notation confusions can happen. For example, if you have any number 5 raised to 1, that means 1 over 5. If you have u raised to negative 1, that means 1 over u, right? That's yes, true for numbers, but for functions, when you see this notation, f inverse is 1 over f. And on the other hand, whenever you have 1 over f inverse is not 1 over f. I'm sorry, f inverse is not 1 over f. On the other hand, whenever you have to write 1 over f of x, we just write this. We do not use f raised to the negative 1th power notation. Okay, that must be clear. And now, today's video, so let's do one exercise. Verify f inverse of x 1/2 x minus 2 is actually the inverse of the function f of x 2x plus 4. Now the verification. Now in this one, how do you verify that? In order to do that, you have to understand certain thing. Now let me explain that thing over here. Remember composition of functions. Remember f circle g. We have been talking about this stuff. F circle g is f of g of x. Now this is exactly why we did composition functions before inverse function. Now what do you think will happen if I replace my g by what is f of f inverse of x? Or f inverse of f of x? What do you think will happen? Well, using a diagram, it's pretty easy to understand. If you plug, see, f will take this guy, x, let's say, to f of x. So f will do that job. On the other hand, f inverse will take it back to x, right? So f of f inverse x and f inverse of f x is going to be x, or the identity function. So remember this, and now we are going to use that for this problem to verify it. So f of f inverse of x, let's check both. Now you know how to deal with composition functions. So f of f inverse, you write down f inverse here. Now the form of f is 2 times whatever you throw to f, 2 times, it will make it 2 times and add 4, right? Now you are throwing this guy, so just write it down here. Now simplify. 2 times 1/2 is x, 2 times minus 2 is negative 4, and then you have plus 4. See, it will cancel and you have x. So f of f inverse is x, and now let's check the other thing. What do you think will happen? It must be the same, but let's check just to be clear. So f inverse, you write f inverse. Now f of x, that's 2x plus 4. What f inverse does in this case is it will make 1/2 of the input and minus 2. So you write 2x plus 4. Now when you simplify, 2x and 1/2, that's x. 1/2 and 4, that's 2 minus 2. See, it's also x, and this is also true. So yes, this guy is the inverse of this. Now this raises another question. Now in this particular problem, f inverse and f, both of them are given. What if I give you just f and ask you to find inverse? How do you find it? Now that's a step-by-step process. I'm going to teach you 2 techniques for this. 2 techniques. One technique with some intuition skills, another technique is step-by-step technical skill. Step-by-step technique having some technical skills. And let's do that in our next video. Thank you.